ठीक है. So now acids are things that produce protons, or they produce H plus ions. That's what acids do. So they're proton donors. What is weak? Weak means that they ionize partially, or they dissociate partially. Ionize is the correct word. They ionize partially. So they produce fewer H plus one ions. They don't produce a lot of H plus one ions. And we did discuss that any acid could be represented by this thing. It's going to produce an ion, and it's also going to produce an H plus one. And we did discuss that for a weak acid, there's going to be a dissociation constant, which is going to be X minus 1 concentration into H positive concentration divided by the acid concentration, which in this case would be HX. And you could write it as H plus 1 squared because the two products have the same concentration. So you could do this as well. Actually, we did all of that. We did a lot of questions on that as well. We did buffers and we did weak acids. Now the organic part, which is which things are weak acids? First one, number one, you've got alcohols. These are very weak acids. I'm going to write that down later, but let me just tell you that what happens is that you have an alcohol. An alcohol is something that has an OH group. And in this case, what happens is that the H at the end, it dissociates. It ionizes. And R is a carbon chain, remember that. So O minus 1 ion is produced and an H plus 1 ion is given off. Okay, so that's an alcohol that's dissociating. Similarly, you have the second one. Now, alcohols are very weak acids. Ionization is even less. I'd say its ionization is even less compared to water. Now, how many H plus 1 ions were produced by water? Water would produce 1 into 10 power minus 7 mole per dm cube of H plus 1 ions, if you remember that. So, an alcohol is going to produce even lesser than this. The amount of H plus 1 ions that would be produced by an alcohol, that's going to be very, very less. And the dissociation constant for an alcohol would be very less. I don't know if there is, like if I take ethanol and I try to figure out the dissociation constant for ethanol, it's probably going to be, I mean, maybe it's given over here. It's probably going to be a very small value. No, not given. You forget this. Just 1 second. Let me just wanted to see. Just 1 second. This one. So just the idea that alcohols are going to dissociate very, very less. They're even going to be weaker acids compared to water. Water's ionization is greater than an alcohol. So they're extremely weak acids. And also remember, the only acid reaction that they have is only react with very reactive group 1 metals. So they only react with very, very reactive group 1 metals. So for example, you have an alcohol, you have ethanol, which is CH3, CH2, and OH. And OH. So if you react it with sodium, like a very reactive group 1 metal, a salt would be produced. The H would be lost. It's going to produce CH3, CH2, and O minus 1. And over here, it's going to be Na plus 1. Okay. So this is what would happen? Just give me 1 second. Just hold on 1 second. As I said, so a salt would be produced an H2 gas. The H that is displaced is going to react and produce, it's going to produce H2 gas. The H would be displaced. So it's a metal plus acid reaction. But that's it. No reaction, absolutely no reaction with bases or carbonates. ठीक है, absolutely no reaction with bases or carbonates. Anyway, so is this clear that alcohols are very terrible acids? ठीक है, they don't do much.
Yes, sir.
अच्छा, उसके अलावा ये कि apart from that, what else that's going to happen is that alcohols are terrible acids. We're going to find the reason why they're terrible acids. Now, the reason is, and the reason for them being terrible acids. Okay, so the reason why alcohols, and you're going to be asked about this, okay? अस्सलाम वालेकुम। अच्छा रबिया, ये तबीयत कैसी है आपकी? ठीक हो आप?
हाँ जी, मैं ठीक हूँ। रात को तबीयत खराब थी लेकिन अब आई एम बेटर।
अच्छा चलो ठीक है, ज़बरदस्त। तो ये हम ना वीक एसिड्स पढ़े हैं, उसका ऑर्गेनिक वाला पार्ट, ठीक है? वो के वगैरह स्कूल के अंदर हमने कर लिया था, ठीक है? तो उसका ना वीक एसिड्स के वो सारा तो हमने कर लिया, के वगैरह ना। तो उसका हम पढ़ेंगे कौन कौन से वीक एसिड्स हैं। उसका जो ऑर्गेनिक वाला पार्ट है क्वेश्चंस के अंदर ना मिक्स आता है, ठीक है? तो वो हम कर रहे हैं ज़रा। चलो कमिंग, ठीक है? अच्छा कमिंग,
आज का ही लेसन है जो आपने आज पढ़ाया है स्कूल में?
हाँ यही करना है। स्कूल में हमने वो पीएच कर्व ही किया था, लेकिन उसका मैं भेज दूंगा लेक्चर आपको, ठीक है, रिकॉर्डेड।
ओके, सही।
चलिए ठीक है। अच्छा, alcohols are terrible acids. Alcohols have an OH, that H dissociates, ठीक है? So it's the same dissociation equation, HX dissociating to produce X minus 1 and releasing an H plus 1 ion. अच्छा, so the question is, reason why are alcohols such bad acids, ठीक है? कि why don't they dissociate easily? Now the reason for that is कि whenever you have an alcohol, ठीक है, for example you have got CH3 and there is CH2, let's say I have propanol, ठीक है? So there's a carbon chain, there's an O, there's an H, and this is going to dissociate, ionize with a lot of difficulty, ठीक है? Alcohols are not good acids, and it would produce this ion, and an H plus 1 ion would be produced. Now everything depends, okay, how strong an acid is depends on the charge density on this ion. Okay, it depends on the negative charge density on this ion. Because if there's a very strong negative charge on the oxygen atom, then that means that the H plus 1 would be attracted back again, and it would be very hard for the H plus 1 to actually leave. Okay, so if the negative charge is really strong, so this acidity or the acid strength depends entirely on this negative charge density on this ion. Okay, so whenever you have an acid that's dissociating, everything depends on this ion. Okay, how strong is the negative charge? Because if the negative charge is very strong, then it would attract the H plus 1 back again, and it's not going to dissociate. Is this point clear? Ethan, Mohammed, is this clear? Zoha, Nabila?
Yes.
Acha.
Yep.
So everything depends on the negative charge density. Now for alcohols, the reason they're very terrible acids is because it's got very high negative charge density. And the reason it has a very high negative charge density is कि if you remember, carbon chains always have an electron donating effect, which means that, I mean, carbon chains have lots of electrons. Like carbon chain, the carbon has 6 electrons, 6 electrons. So, I mean, whenever you see a carbon chain, that's an electron cloud. I mean, there's lots and lots of electrons over here, right? So, so carbon chains are full of electrons. 6 electrons, 6 electrons, 6 electrons. That's a total of 18 electrons. You add in the hydrogen atoms as well. So you've got 25 electrons approximately in this carbon chain. So any group that gets attached to a carbon chain, electrons are going to be pushed onto that group. So in this case, if you have oxygen over here, the alkyl chain over here will have an electron. Alkyl chain will have an electron donating effect. Is this part also clear?
Yes, sir.
So the alkyl chain will have an electron donating effect, and which is why the negative charge over here would have a very high charge density, because electrons are getting pushed from the carbon chain onto this oxygen as well. So over here there's a lot of negative charge. So it's not going to allow the H+1 to go away. The H+1 would be very strongly attracted to this. So that's the reason why alcohols are such terrible acids. So you'll be asked about this question. So reason why alcohols are terrible acids. So the correct answer that you're going to write is, I mean, the way you're going to phrase this is that alkyl chain has electron donating effect. And what does it do which increases electron density on the ion, which is, in this case, it's going to be CH3, CH2. There's another CH2 and O minus 1 ion. So alkyl chains should have been have TK. They have electron donating effect, which increases electron density on the ion, making it unstable. I mean, the word that you're going to write is that it becomes unstable. Unstable meaning that it would start attracting the H+1. Unstable means that it's going to change, that it would immediately attract the H+1 and change into this one. So it's going to be very unstable, and making it unstable. There's going to be strong attraction for H+1. Hence, less dissociation. Is this clear?
Yes, sir.
Yes.
Okay, so there's going to be less dissociation. So that's alcohols. That's the reason why alcohols are such terrible acids. And the only reaction that they ever undergo is a reaction with sodium or any group 1 metal. That's it. They don't have any reaction with bases or carbonates, nothing. Okay, so you don't really call them acids in the first place, because the dissociation is so bad. The next one. So the next one is, let's talk about carboxylic acids. Nee, Saqib, I didn't get your question. Well,
Sir, I mean that group 1 metals are stored under oil and group 2 as well. So
नहीं लेकिन वो oil doesn't react ना, क्योंकि oil is probably alkane and alkene, ठीक है? और मतलब oil में there is no acidic property. मतलब oil is not alcohol, ठीक है? मतलब वो जो तुम बात कर रहे हो ना सोडियम की, that is only with alcohols. So oil is not alcohol. Saqib, is this clear?
yes, sir.
So there's not going to be any reaction if you store sodium in oil. I said now next one, carboxylic acid. You already know what happens to carboxylic acids. They are I mean, they're complete acids. I mean, you can call them acids. I mean, they have all acid properties, except for the fact that they are weak acids. But they have all the properties. Like whenever you think of an acid, I mean, you can't call alcohols acids because they don't undergo most of the reactions. But carboxylic acids, they undergo pretty much all reactions, all acid properties, all reactions, etc. Everything. Relatively speaking, they are the strongest organic acids. Like if you compare them with the alcohols, they are strong. Okay, they are the strongest acids. So what happens in carboxylic acids? Why do they dissociate? Why do they react or ionize? First thing, I'm going to just quickly write the reactions of all. Like if I have ethanoic acid CH3COOH, it would react with sodium metal. It would form salt and H2. As if I react it with base, it will react with a base. And it's going to form again a salt and plus water. And similarly, it would also react with a carbonate. Okay, acids react with carbonates. And in that case, they are going to produce again a salt. A water molecule and carbon dioxide. And they also react with ammonia to produce ammonium salts. Okay, acid plus ammonia produces ammonium salts, which is going to be CH3CO -1 and NH4 +1. So every time you'll notice that the H at the end, it kind of gets it loses that H. I mean, it gets replaced by something else, but it eventually ends up losing that H+1. So it's acting as an acid. Every time it's losing an H+1 to OH to form water, losing an H+1 to CO3 to form water and carbon dioxide, losing an H+1 to NH3, and that turns into NH4+1. So every time it is behaving as an acid. So why are they such good acids, relatively speaking? So here's our propanoic acid molecule. So propanoic acid would be double bond O, NOH. It also has NOH.
Sir,
Yes.
sir, when we say that sodium will react with with alcohols, right? So how does it happen? The acid, like basically alcohol will dissociate on its own, and then sodium will be attracted to it. Is that how it goes?
No, it's because sodium is very reactive and sodium likes to. I mean, this one, right?
Okay.
Can't get.
Yes.
Sodium is extremely. I mean, this is more like a redox reaction. Sodium likes to lose electrons, okay? So it gives that electron to H. H gains that electron to form H2 gas, and so H is gone. There's O-1 left, and sodium has turned into an ion +1.
Okay. 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 Okay.
So the metal plus acid reaction is more of a redox reaction. So anyways, this one. This is a carboxylic acid. This is propanoic acid. So the question is, why, like compared to an alcohol, why is it such a good acid? Even though both of them are weak acids, but it's a much better acid. So you got O-1 and the H+1 is produced. So carboxylic acid readily wants to ionize. And remember, again, everything revolves around this thing, the X-1 ion, this negative ion over here. Everything depends on this. That the charge density over here, is it going to be high or low? Because if it's high, the H+1 would be attracted back again. So because it's a good acid, it's got a low charge density. Now, why does it have a low charge density? Well, why is the negative charge density so? Why is the negative charge density not so concentrated at this point? Why doesn't it attract the H+1 back again? Okay, so at the moment it's not. It's behaving as a good acid. It's not attracting the H+1 back again that strongly. The reason is this C double bond O, because remember there's another oxygen over here. And what does oxygen like to do? Oxygen likes to, I mean, this oxygen over here is very electronegative. So what it would do is, if you know that oxygen is electronegative, what it would do is this oxygen would start pulling, like the H went away, leaving its electrons over here. The negative charge was all concentrated at this point. But the electrons are not going to stay over there. I mean, there was an O and H bond. H left its electron, went away, leaving the electrons. Now, the electrons are not going to stay at that point. They will spread out because there's an oxygen at the other end, which is pulling those electrons. Eventually, what would happen is that the negative charge, all of it would eventually get distributed between the two oxygen atoms, right? So there's not going to be actually a double bond over here. The electrons, I mean, there would be two oxygen atoms. It's going to more. It's, I mean, it should have been C double bond O and O minus one, right? With the negative charge concentrated at this point. But what eventually happens is that because both of them are oxygen atoms, the electrons eventually get attracted and get pulled between the two oxygen atoms. So the electron density, the double bond, and I mean, there's a pi bond over here, and there's negative charge over here. They all kind of mix up. So the whole electron density kind of gets distributed between the two oxygen atoms, which is why you have a low charge density, because the electrons are now more distributed. So if the electrons get distributed over a wider area, then the negative charge kind of becomes it kind of becomes less effective, less able to pull the H+1 ion. Is this clear? Yes or no? Is
Yes,
this
sir.
clear? Mohammed, is this clear? Binahil?
Yes.
Binati? So compared to the previous one just had electron donating effect. Like you just had a carbon chain that was pulling the or pushing the electrons onto the oxygen. There was nothing that was withdrawing the electrons. So the electron density was kind of really strong at this point, which is why it was attracting the H+1 back again. The reason this is such a good acid is it still has pretty much the same structure, but you have another oxygen over here, which is kind of pulling the electrons away from this side. So the negative charge at this point would kind of become less concentrated, and the H+1 would no longer be that strongly attracted to it because of this oxygen atom. So your ion, your X-1 ion has low charge density. So the answer to this one is going to be that, so now your answer to this one would be that there's oxygen in C double bond O has an electron withdrawing effect. So it has an electron withdrawing effect, which decreases electron density on the RCOO minus 1 ion. You get this ion over here, the electron density is lesser now. So which decreases electron density on RCO minus 1 ion, and because of that, the ion becomes stable. And it no longer will attract the H+1 that strongly.
Sir, can there be dative bond between them?
इसमें H+1 and this one?
Yes, oxygen and H+1, or the other oxygen.
No, that can happen, but the thing is, and that will, it's probably, remember it's partial ionization. So that means the H+1 is not going to completely go away. It's just relatively speaking a stronger acid. I mean, the H plus one is going to be less attracted to it because the electrons are now more distributed. Is this point clear?
G.
Okay, initially the electrons were all concentrated at this point, right? And the H plus one was attracted to this oxygen, right? But because of this other oxygen, the electrons are kind of more distributed now. So the H plus one is no longer very strongly attracted to these electrons. Is this clear?
G.
So relatively speaking, compared to alcohols, that is possible. The H plus one can still come back and can form this molecule back again, which it will. It's a weak acid, but relatively speaking, compared to an alcohol, it's a much better acid now. अच्छा अब ये कि stable and they will be lesser. So ion becomes stable and they will be lesser. There will be lesser attraction for H plus one ions. So that's why carboxylic acids are such, or relatively speaking, good acids, which is why they can behave like proper acids. So that is about carboxylic acids. You should know, I mean, this is the part that's important. Let me just highlight this. Okay, so, okay, not like this. We'll just put a box around it, just a second. So this explanation, you're going to be frequently asked about this explanation. And the other one was the previous explanation why alcohols are such bad acids. You have to frequently give reasons for this. Now, you have done alcohols and carboxylic acids. There's another one, which is related to benzene. Okay, this is new. This is one that you haven't done. Inorganic. Okay, so we'll just briefly go over this. So that's known as a phenol. Okay, because when we do attempt past papers, a lot of questions would be on phenol, so I think it's better to do the acid part over here. So phenol is this thing. Phenol is a benzene ring, and that benzene ring has a benzene electron cloud in the middle, and there's an OH group. It also has an OH group. So I'm going to briefly explain, or very quickly explain what this thing is. What I'm just going to explain is, and in the briefest possible way, we're just focusing on the acid part. When you see this ring structure, you've seen this ring structure very often in AS organic as well. In a lot of molecules, I mean, this is a very common structure. It's a very stable structure present in a lot of places. So a lot of molecules have this. So it's a very stable arrangement. Actually, graphite is something like this. I mean, graphite is just multiple benzenes. If you connect multiple benzenes together, that's what graphite is. So it's a pretty stable arrangement. What this actually is, it's 6 carbon atoms, okay, all bonded in a cyclic manner. So they're all bonded in a cyclic manner with alternating double bonds. I mean, that's the simplest possible explanation for this. And there's an OH over here. And each of the carbon atom, the fourth bond would be with a hydrogen atom. So that's the simplest version of what a benzene molecule is. If you want to understand what a benzene molecule looks like, it's a cyclic 6 carbon atom cyclic structure, and each carbon atom is making a double bond. What happens is, why do you show a ring then? The reason you show a ring is that the double bonds kind of get mixed up, because double bonds have pi electron clouds, which means that all of them, they kind of start overlapping with each other, and they start getting mixed up. So we'll just first study this structure in a little bit detail, which is that when carbon makes a double bond, does anyone remember what type of hybridization is that?
sp2.
Okay, so that is sp2 hybridized carbon atom, which means that carbon has 4 electrons, right? So out of the 4, 1 electron bonds with one atom, 1 electron bonds with another atom, 1 electron bonds with another atom. So it makes 3 bonds. So 3 of the electrons, they get stretched in different directions by those atoms. They're trying to bond with them. Now the carbon's 4th electron, no one is initially interested in that. So there's a p orbital which has the 4th electron, but it's completely unused at the beginning. So benzene is sp2 hybridized. So it's basically a carbon atom that's making 3 bonds. Then the next carbon atom that's also making 3 bonds. Then you have the 3rd carbon atom that's also making 3 bonds. The 4th carbon atom that's also making 3 bonds, and then you have the last 6th carbon atom. They're all making 3 bonds each. The outer bond is made with NH. And we can have an OH over here. And each of the carbon atom has a spare orbital. This one over here. Every single one of them has a spare orbital. So this one has this 4th electron, unused 4th electron. Everyone has this 4th p orbital. When orbitals are in parallel, what type of bonding do they do?
Pi.
They form a pi bond. So these two can sort of start overlapping and they would form a pi bond. These two over here can start to overlap and they can form a pi bond, and these two can overlap and they could form a pi bond. So you will get 3 alternating double bonds. Is this clear?
Yes, sir.
Okay. Is this clear to everyone? Rabia, is this clear? Nabila, Zoha?
Yes, sir.
Achha, but the problem comes, okay, why do you show a ring? The reason you show a ring is that at the end of the day, it's not just 2 orbitals that are parallel to each other. It's all the 6 orbitals are parallel to each other. All of them are parallel to each other. So if this orbital is overlapping with this orbital can also overlap with this orbital over here. So they all can kind of overlap with each other. Okay, so the overlapping, all the 6 orbitals would eventually, they would start overlapping, and the double bonds are going to get mixed up. So instead of having a double bond that would be right at this point, the electrons would kind of start overlapping with each other and they would all kind of get mixed up. So there's going to be this delocalized electron cloud, and that is what your ring represents. I mean, it started off with just 3 double bonds, but the double bonds kind of got mixed up. And eventually you had these 6 orbitals, and all of them, they ended up overlapping with each other. So at the end of the day, you have this electron cloud that's covering all of the carbon atoms above and below. So there's a delocalized electron cloud that's known as a benzene ring. Okay, is this clear? Yes or no? Is this clear?
Yes, sir.
Yes.
Yes, sir.
Achha, theek hai. So I just wanted to give you a brief idea of what a benzene is. I just wanted to discuss the acid part, whether it's a strong acid or is it a weak acid. We did discuss carboxylic acids. We did discuss alcohols. The third one that we have to discuss is phenols. Phenols are, remember, they're not alcohols, okay? They're different from alcohols. Phenols are benzene attached to NOH. So we'll discuss this. We'll continue tomorrow then, okay? And we'll discuss this, only the acid part. Okay? Why is it a strong acid, or is it a weak acid? Okay? So we'll come to a conclusion tomorrow. So okay, let's continue tomorrow.
Yes, sir.
Okay.
Thank
Take
you.
take
Allah
care.
Hafiz.
Allah Hafiz. Allah Hafiz.